The fixed effect, they say they have a small number of levels. Like gender has how many levels too? They decided age group, how many groups they can do? 20? Can say 20 groups, right? Age. Maybe 5 maximum, maybe 3 maximum. So still there is a limited number of the factors you can have. Yes. On the research. But the research, it depends on your study.
There is no limit in the category.
Even if you make it 10, still it is a limited.
الريسيرش بيحددها على أي أساس؟ يعني there is
always you go back to the previous study. What we are trying to do always replicate the previous study. Let's we do literature review. So it will be according to the previous study. So to compare your finding, this is why we have a discussions at the end of your paper. There is a discussion. This discussion you should mention something about previous study, which is if your research exactly having the same parameter, like studying adult, for example, then you might look at the study that discuss adult and they compare your finding. But if you study about adult and you find a paper on children, is that replicate? No, it's not fitting your research. So anything it will be depends on your the previous study that you're trying to replicate always. So any one of you having research project. So now you go back to the previous research, how they look into the factors, what factor that they included, correct? So that will be easier for you in the discussions to see whether age having an impact or not. If they have an impact, now look at the previous study. Did they find there is impact on age? If yes, then mention that. If no, then you don't replicate it. And you need to do the justification why that happened. Maybe it could be a sampling issue. So this is the importance of the research. We're trying to just replicate previous research. So now what we're saying here, if an effect such as gender, not sure of this statement here. So they say males and females, both of them can be considered by the researcher. As I mentioned, they can consider only males, or they can consider only females, or they can consider both of them. Still, this is decided by the researcher. Now, if an effect, such as gender, affect the outcome, so it is a fixed effect. So if it does have an effect on outcome, then I'll call it, yes, the gender, it is a fixed effect and it is significant. Now, repeatable level, if we want to replicate the study, the same level of the gender would be chosen. Yeah. So if there is a previous study, consider both male and females, and I'm trying to replicate the same study. So we're having the same outcome, but this replicate this study in my populations. The previous study done in US, I'm trying to replicate here in Saudi population. So what do you think? The previous study considered both male and female. So now here in this study, what do you think? Are you going to include only males? Or female or both? Both. Because you're trying to replicate that study, so you need to choose similar. Yep.
Doctor, in case I will adjust the age.
Also, you may not be able to compare your finding. Let's say that you included your sample age from 14 years and above, and they have 18 and above. So that's different, right? So likely you cannot say my study having similar finding to their study. Yeah. Now an example of fix, we give so many examples of fix, but treatment. Treatment can be what? A fix.
Yes.
Yes.
How it can be a fix? Because a treatment, research, who decides the treatment?
Research.
Researcher. Who decides the level of treatment? Researcher. So researcher may say I'm going to give A and B drug. Or researcher may say I'm going to give A and B and C. Or a researcher may say I'm going to give drug A only. So this is determined completely by the researcher. So now treatment should be considered as fixed treatment. Notation for this fixed model. So we have, are you familiar with this here? This is exactly the same as we study in linear regressions. Exactly the same. It is a fix. So now, this beta here include everything, include beta 0, the intercept, and the slopes for the variables. So now, this is just the standard linear regressions. Y always represent the vector of observed outcome. This is the outcome trying to observe. It can be lead level, it can be cholesterol level, it can be any variable that numerically. The beta, which is unknown vectors of the fixed effect parameters or factors with unknown design, which is the x. X, it can be age, it can be gender, it can be treatment. All the fixed effect factors. So what this is the betas. This beta is unknown, but it can be estimated from SPSS. From SAS and SPSS. Statistical package will estimate this for you. Now this epsilon, what do you think of this?
Error.
This is error, which is the amount of unexplained variations that I'm trying to reduce. So without adding random effect, I'm not going to be able to reduce this. So later, I'm going to add to this here a random effect so I can reduce this error. Okay? Now the random. So the random effect, which is a variable that, any variable that associated with sampling procedures, that is called random effect. So subject, I can choose subject randomly, so it is associated with a sampling procedure, right?
Yeah.
So the subject would be considered as a random. Center, similarly, I mentioned that, so also will be considered as a random, right? School would be considered as a random. So all these are random effect. So again, if we want to replicate the study, different subjects, school, center may be chosen. You agree with this statement? Yes. So now, because you have many levels of these, likely if trying to replicate the study after 5 years or 2 years, same patient may not be selected, or same center may not be selected, or same school may not be selected, because the different levels that you're selecting from. So now the presence of this random effect might introduce correlations, remember correlations, between subjects within the unit, and this might increase what? The amount of explained variation and reduce the amount of unexplained variations. So the example of random effect factor, so in clinical trials, drug A, drug B, and drug C are applied to patients in various clinical centers. So clinical center here considered as what? As a random. And what about drugs?
Text.
Consider as a fixed, yes. Now, how we mathematically how we note that notations for this? So the notation would be a mixed now. Before we model what? Fixed model. Now we have a mixed. Why? Because we are adding the random. So this red you see here. So now this black here exactly the same as the mixed, right? The fixed. But now I'm adding this red, which is a random. Now we know how to explain this here, which is the unknown parameter that estimated from this statistical package. This is the fixed effect matrix. Now for these, again the gamma serving just like the betas. So the gamma, which is unknown vectors again of the random effect variables with unknown design matrix, which is Z. So the gamma serving the same thing as a fixed, as a betas. So it is unknown. It can be estimated by the statistical package. Okay, but it will be introduced then into the model. Now the Z, which is what? This is the random effect. It can be school, it can be subject, it can be center, it can be hospital. Excellent again. So what do you think of this now? The error? The error, right? So the error here, what do you think comparing this error to this error? This would be larger, right? This error would be larger. Here will be reduced. Why? Because of adding this random effect. It's going to explain better than the one without. Covariance structures. Now, since the random effect contributes to the variance covariance structures, then there is a need of adjusting the various covariance structures. So we're going to have many different variance covariance structures to model it, and then see which one is better fit our data. So by default, the level of random effect are uncorrelated and also have the same variance. So by default, they're assuming that, okay, we are doing compound symmetry, if you remember compound symmetry. So they're assuming just correlated, or they're assuming that the various covariance are equal over time, which is the compound symmetry. So here, similarly, assuming by default. But now this it's not going to be the case in mixed models, which is we're going to have many different covariance structures that we may use. One of them is the compound symmetry itself. So now we must select one various covariance structures to model our data. Here I have only 5, but there is more than 5 structures. We can learn more about these specifically. So we have something called unstructured variance covariance. SAS know this as UN. So for example, if you're going to write a code, you have to say just UN. Type equal UN. SAS will know that you want to implement the analysis considering the variance covariance structure and structure.
By default, level of random effect are uncorrelated and have the same variance. This is assumption or?
No, it's not assumptions. This is by default. If I'm not going to, just like doing ANOVA models. So I'm still not producing the power of mixed model yet. So once I'm going to introduce this here, the UN, type equal UN, Now I'm assuming that the variance covariance structure following this UN, which is unstructured. The compound symmetry is saying what? The variance covariance are equal over time, right? So now the unstructured is saying no, it is unstructured. It can be anything. Okay, there is no specific distributions for the variance covariance structures. Compound symmetry also, you know, is one of these, but we not prefer it. And now, anytime you compare these with compound symmetry, you'll find the other one is better than compound symmetry. Okay, so this is just like you are doing ANOVA again. Just like a default, you are doing ANOVA. If you have a complete data, you run ANOVA, right? And then you run mixed model with compound symmetry, you will get exactly the same value, exactly the same result. But that given that you have a complete data to do that. So now there is what is called first order autoregressive. SAS know this as AR1, AR parentheses 1. Okay, so this is the first order autoregressive. So now, the assuming here that the variance covariance structure takes what is called first order autoregressive. So if you say type equal AR parentheses 1, SAS is going to produce this for you. Any one of these have different models. So you cannot report all of them. You have to choose one of them, one of these. Toplets, also it is another model. I'm going to be specific for each one of these next lecture. So we're going to study the matrix itself for each of these, how it look like, okay? And maybe, you know, how to choose the specific models. Also, there is another one, it's called variance component. So SAS know this as a VC. If you say type equal VC, SAS will generate that for you. So this is, as always, it is good idea to compare your initial model. If you start with this, you need to compare all these models to each one, and then you can choose the best variance covariance structures, and then you're going to report the model with the best parameters, which is, I think it should be mentioned later in the next lecture. There is a specific parameter that you decide. It will tell you which one is better fit for your data. So we have to use that. Now there is something already you know about this. In order to use the mixed model, we have to prepare our data. Yes, so likely you're going to receive the data from clinicians look like the wide format because it's easy for them. Now we need to change these settings to long format. It is a must. If you're trying to use mixed model, it's a must that you have to, you know, restructure your data and make it look like this one. I think we have tried this before, right? But it's always good if you practice how you are doing this alone, maybe with help, without help, so you can get the idea of how you are going to do this. This is again the SAS code, how we transferring this data. I'm just giving an example. You can apply this example to anyone, right? So yeah, so now here, this is your data, SAS keyword. You put in a name here. This is your new data. You can call it long. Set, this is a SAS keyword. This is from old data set that you're trying to read from. Now, you see why here? this is what your new variable is. The new variable that you're going to add. And always this can be lead level. For example, if you are measuring lead, then you can call it lead, right? Now you bring in here the lead at week zero. Semicolon, right? And this is give you the time interval at 0 because it measured at 0 here. And now then just the output. So output is going to produce this here, right? And same thing you are doing this for the other one. Let again at week 1, make sure you assign it that 1. So it's going to produce the 0, 1, 2, 3 for each one, and then it's going to start over again, do for the second. This is the first patient ID and the timing here, baseline, week 1, week 2, week 3, and so on. And again, going to replicate the second patients and going to all the measures together. So it's going to do that. Once it's finished, this and options, if you don't like to see the old variables, you can drop them, which is these are the old variables. You can drop them from your data. And now you're going to get only, after you drop them, you're going to get this data you knew. Now you can use this for your the mixed models. In SAS, how you do that? It's how you do it in SAS. I see some of you still interested in SAS, right? So now, if you use SAS, how you make you move from wide format to long format, which is using this approach. It is many steps. So which one you preferring using the SAS?
SAS.
What the S?
Can I use both? SAS and
Uh-huh.
Can I
Sorry?
use both? SAS
You
and
can use both and see what does.
no. I mean, this is
Yeah.
in that case, I can use both SAS and space.
You can, but your report should be based on what? Yeah. So see how this works in